Dear students, under the lecture series on graph theory, here we have lecture 9. The problem is, let G be a k regular bigraph with bipartition v1, v2 and k greater than 0. We have to prove that the cardinality of v1 is equal to the cardinality of v2. So let us prove this now. So first we shall write what is given. It is given that G is a k regular bigraph with bipartition v1, v2. So we shall write that. So this implies that every vertex of G has exactly degree k. Because it is a k regular bigraph, every vertex will have degree k. So we have written that every vertex of G has degree exactly k. Also, this v1 comma v2 is the bipartition of the vertex set capital V, and so capital V can be written as v1 union v2. So let us write that. That is, we have V to be equal to v1 union v2. Now what we have to prove? We have to prove that the cardinality of v1 is equal to cardinality of v2. So let us write that. In order to prove this, we shall recollect the concept of a bipartite graph. In a bipartite graph, we know that every edge connects a vertex in V1 to a vertex in V2. This is by the definition of the bipartite graph. So we can say that the sum of all the degrees of V1 will be equal to the sum of the degrees of V2, because every edge connects a vertex in V1 to V2. So let us write that. So I have written that. So in a bipartite graph, if you consider an edge, it will connect a vertex in V1 to a vertex in V2. So we can say that if you sum up the degree of all vertices from the vertex set V1, it will be equal to the degree of all vertices from the vertex set V2. Also, since G is k regular, we can say that each vertex in the set V1 will have degree k, and also each vertex in the set V2 will also have degree k. So, if we sum up all the degrees of the vertices from V1, since each vertex will have degree k, it will be equal to k into modulus of V. So, let me write it, you will understand it. So each vertex in V1 has degree k. So if we sum up all the degrees of the vertices from V1, since each is having degree k, it will be k into the number of vertices. So modulus of V1. Let us mark it as equation 2. Say in the same way, all the vertices in V2 will have degree k, and when we sum up all those vertices, it will be equal to k into the number of vertices in the set V2, that is modulus of V2. Now we will compare 1, 2 and 3. So from 1 we know that, in 1 we know that summation V from V is V1 d of V is equal to summation V from V2 d of V. So these two are equal. We know this. So using this and substituting 2 here and 3 here, what we will get? That is substituting 2 and 3 in 1, we get, so since this and this are equal, from 1 we can say that k into modulus of V1 will be equal to k into modulus of V2. Since this k is greater than 0, we can cancel these two, and therefore we will get modulus of V1 is equal to modulus of V2. And hence we have proved the required result. This is what we wanted to prove. The number of vertices of V1 is equal to the number of vertices of V2. So hence we have proved this. So I hope you would have understood this problem. In our next video, we will learn what are subgraphs, what are the different types of subgraphs, and a very significant theorem under the concept of subgraph. That is, the maximum number of lines among all p-point graphs with no triangles is integral value of p square by 4. It's a very significant theorem which is an expected 15-mark question. So kindly follow the upcoming video lecture on this topic. Thank you.